In this session, we are going to discuss about atomic absorption spectroscopy. If we look into the history of atomic spectroscopy, it dates back to 1802, where Wollaston observed the formation of absorption lines in the solar system. In the year 1914, the hollow cathode lamp was identified. In the year 1955, Alan Walsh introduced the first analytical atomic absorption spectrophotometer. In 1959, the first commercial AAS was introduced. In 1960s, Yelvov and Mashman described the graphite furnace. Atomic absorption spectroscopy is commonly used for the analysis of metals solutions. In case of atomic absorption spectroscopy, the sample is sprayed onto the flame, the sample vaporizes. So these neutral metal atoms, which are formed during the vaporization of the molecules, absorb the specific radiation which is produced by the source. We use either a hollow cathode lamp or we use an electrodeless discharge lamp as a source of radiation. They absorb the radiation, they move from the ground state to the excited state. The intensity of the radiation which is absorbed is in turn measured with the help of a photomultiplier tube. This particular technique is highly sensitive that it is capable of determining even to the extent of parts per billion. The concentration measurements are usually carried out by plotting a calibration curve, or we call it as the working standard curve. So the working standard curve is plotted by taking the standard metal element which has to be analyzed. After plotting the working standard curve, the sample will be analyzed and the concentration of the metal which is present in the given sample can be extrapolated from the calibration graph. This is the most commonly used technique, especially for the estimation of metals and metalloids which are present in the environmental samples.